All right, so hopefully everyone has opened up SimVascular now. So once we open up the program, our screens might look something like this. So at this moment, everything is pretty much empty. So we'll get started by going to File in the top right corner, and we can open an SV project, or in our case, we're going to start from scratch. So we'll be creating an SV project, but if you are following along with the coronary normal clinical case example, you can open that up here. So we'll go and I'll create an SV project. Oops, sorry. Pop-up is here. So for your project name, you can name it whatever you'd like, but we recommend just naming it after whatever you're trying to model. So you can name this coronary model. And just as a general guideline, you usually don't want to include any special characters in your naming because it might produce an error in the system. So we have our coronary model project here on the left-hand side. You'll notice that now the SV data manager is populated with all the different fields or different components of the pipeline, starting with images. And however, in the center of our screen, the display still looks empty. And that's because we haven't uploaded any image files yet. So we go to images, we can add or replace an image. So you can right click on images and this pop-up will appear. So we will be adding an image in. So you can click on this, add replace image. And I'm going to add in a .vti image file. And just as a note for images, they're typically .vti files for medical imaging data. However, they can also be, you might also have a sometimes .vtk file, or another common form for CT scans and other imaging to be stored in is DICOM files. So DICOM files are basically stacks of images, and SimVascular can actually take those DICOM files and convert it to a VTI for you. So I'll open that up. And do you want to copy the image as VTI? Usually you can click yes for this. Do you want to scale the image? This could be if you wanted to scale it from millimeters to centimeters or something else. And we usually just click no. And then you can name your image. So I'll just name this after what it actually is. So coronary model. And then it'll take a few moments for the images to load into SimVascular, since the image files can be quite large. And just wait for a moment as it loads. So as soon as it loads, you'll notice that the display screens will not be empty anymore. So there we go. So right now we have our 4 display screens that are now filled with the images. So before we head into moving around and viewing our image, something to note that I will briefly discuss are the 3 anatomical planes and this display view here. So the 3 anatomical planes that are typically used in medical imaging are axial, coronal, and sagittal. So axial in red, coronal in blue, and sagittal in green. And the 4th display screen on SimVascular is a 3D display which just combines all of the 3 cross sections. So to help us better understand these anatomical planes, I'll go over a few figures and diagrams explaining each plane. So I'm going to head over to our figures. All right, So to help us understand these anatomical planes that are used on SimVascular, let's take a look at a few diagrams, and we'll start off by talking about anatomical position. So whenever we say that someone is standing in anatomical position, this means that their feet are shoulder width apart, they're standing with their arms to the side, and their palms facing forward. And when we discuss anatomy, we always talk about it from the patient's perspective, not the observer. So this just means that the patient's right side will be on the observer's left and vice versa. Kind of like, sort of just like a mirror image. Moving on to our first body plane, we have the axial plane. So the axial plane is what we would see if we were standing below the patient's feet and looking up. So the axial plane divides the body into upper and lower parts. And the axial plane of view is a horizontal plane. Next, we have the coronal plane. So the coronal plane is what we would see if we were standing in front of the patient and looking straight at them. So the coronal plane divides the body into front and back parts. And the third and final plane we have is called the sagittal plane. So the sagittal plane is what we would see if we were standing at and looking at the patient from the side. So the sagittal plane divides the body into left and right parts. So hopefully this quick overview helped us become a little bit more familiar with the planes and the display screens on SimVascular. So we'll head back to the SimVascular application and continue by talking about a tool used for viewing images called volume visualization. Right, so we're back on SimVascular, and what we see here is going to move my video up a bit. So we'll see that at this point we have these lines going through each of our display screens. So this is what we can toggle around. So as we toggle around, you'll notice that the other display screens are moving a bit. And we can do this for each of them. So to use volume visualization, we will right click on or double click the image file that we just named. And then this volume visualization will pop up on the right side of the screen, and we can select volume rendering. So this checking this box will just enable us to see the images in a 3D view. So I'll check it, and now that it's checked, it might take a moment or so to load in. And this volume rendering can be quite computationally taxing, so we just recommend turning it off when you're not using it. So it's a little bit hard to just see the 3D display, so we can actually enlarge this display screen. And you can do this for any of the display screens by hovering over the right corner and clicking on the blue square. So clicking on this square will enlarge the display so that it takes up the entire display. So right now we can see that some of the 3D components, and there's the cross sections though sometimes get in the way if we just want to see the model itself. So what we can do is click on the plus and unselect, turn off the crosshairs. So the crosshairs are just the intersections of all the different planes. And if we turn that off or click it so that it's not checked anymore, we'll see a much clearer view of the model. So I'm just going to go back for a second and leave this volume rendering up. So I'm going to minimize the display so that all the other ones we can see the other ones as well. So how volume rendering works is there's two histograms here, and the really, really high point just indicates that there's a lot of color showing up there. So what we want to try and do is to set